The lone and L2 phases are series connected to deliver higher voltage to the DC feeder. The positive line of the DC feeder connects to the series connection of the lone and L2 phases, while the load connects to the L3 phase. This setup enables the UPS to supply a greater voltage to the load than would be feasible if the lone and L2 phases were connected in parallel. The fundamental reason for a series connection over a parallel connection lies in voltage amplification. In a series circuit, the voltages across individual components accumulate to determine the total voltage across the entire circuit. Conversely, in a parallel circuit, the voltage across each component remains identical to the voltage across the whole circuit. The UPS in the scenario demands a higher voltage output to the load than a parallel configuration of the lone and L2 phases could provide. By wiring the lone and L2 phases in series, the UPS achieves the necessary voltage boost. The principle behind series connections involves the additive nature of voltages across components. Imagine a simple circuit with two resistors wired in series. The total voltage across both resistors equals the sum of the voltage drop across each individual resistor. This voltage addition is the key advantage exploited in the UPS system. In contrast, a parallel connection maintains the same voltage across all branches. If you have two resistors in parallel connected to a 120 volt source, each resistor experiences 120 volts. While parallel connections are useful for increasing current capacity, they don't increase voltage. Consider the implications for the DC feeder. The DC feeder requires a specific voltage level to operate correctly. If the voltage is too low, the equipment connected to the UPS may not function properly. If the voltage is too high, the equipment could be damaged. The series connection of lone and L2 is a deliberate design choice to match the voltage requirements of the DC feeder and the connected load. Let's examine a simplified scenario. Suppose each phase, lone and L2, provides 120 volts. When connected in series, the resulting voltage is approximately 240 volts, ignoring any phase angle considerations for simplicity. This higher voltage is then fed to the DC feeder. If lone and L2 were connected in parallel, the voltage would remain at 120 volts, insufficient for the DC feeder's needs. Now consider the L3 phase, which carries the load connection. The specific role of L3 depends on the overall UPS system design. It may serve as a neutral or a separate phase depending on the voltage requirements of the load. The load is typically connected to L3 to complete the circuit and allow power to flow from the UPS to the protected equipment. Understanding the purpose of each phase is essential for troubleshooting and maintaining the UPS system. Incorrect wiring can lead to malfunction, damage, or even safety hazards. When working with a UPS system, always refer to the manufacturer's documentation and follow established safety procedures. A qualified electrician should perform installations and repairs. The selection of a 1600 amps 3-pole main breaker is also significant. The breaker's amperage rating indicates the maximum current it can safely handle. It's chosen to protect the UPS system and the connected circuits from overcurrent conditions such as short circuits or excessive loads. The 3-pole configuration suggests a 3-phase system where each pole corresponds to one of the 3 phases lone, L2, and L3. This breaker acts as a primary disconnect for the entire UPS system, allowing for safe isolation during maintenance or emergencies. To further elaborate on the voltage differences between series and parallel connections, think of it like batteries. If you connect two 1.5 volts batteries in series, the total voltage is 3 volts. If you connect them in parallel, the voltage remains 1.5 volts, but the current capacity doubles. This analogy highlights the fundamental principle behind the UPS design. A series connection prioritizes voltage, while parallel connections prioritize current. In the context of a UPS system, maintaining the correct voltage is paramount for reliable operation. The UPS relies on its battery bank to provide power during outages. The DC feeder delivers this battery power to the inverter section of the UPS, which converts it to alternating current AC to power the connected equipment. The inverter requires a specific DC voltage to operate efficiently. The series connection of LON and L2 ensures that the DC feeder receives the correct voltage, maximizing the UPS performance and runtime. In summary, the series connection of the LON and L2 phases is a deliberate engineering choice to provide the necessary voltage to the DC feeder in the UPS system. This configuration leverages the voltage additive property of series circuits, ensuring optimal performance and reliability of the UPS in supplying power to critical loads. This also protects the equipment from overcurrents by using the 1600 amps breaker. If there is ever a problem, the breaker will trip, protecting the UPS. There are several key considerations when installing and maintaining a UPS system with this type of configuration. Firstly, ensure proper wiring. Incorrect wiring can have severe consequences, including equipment damage and safety hazards. Double-check all connections and verify that they match the manufacturer's specifications. Secondly, monitor voltage levels. Regularly measure the voltage at the DC feeder to ensure that it falls within the acceptable range. Deviations from the specified voltage may indicate a problem with the UPS system or the battery bank. Thirdly, inspect the breaker. Periodically inspect the 1600 amps breaker to ensure that it is functioning correctly. Look for signs of damage or overheating. Test the breaker to verify that it trips under overcurrent conditions. Fourthly, follow safety procedures. Always follow established safety procedures when working with electrical equipment. To energize the circuit before making any connections or repairs. Wear appropriate personal protective equipment. Fifthly, understand the system design. Gain a thorough understanding of the UPS system's design and operation. This knowledge will enable you to troubleshoot problems effectively and maintain the system properly. Moreover, the choice of series connection for LON and L2 might also be influenced by the specific voltage requirements of the batteries themselves within the UPS. Many UPS systems utilize a battery bank with a relatively high DC voltage. The series connection of the AC phases could be a design strategy to efficiently interface with this high-voltage DC battery bank, minimizing the need for additional voltage conversion circuitry. This simplification can improve the overall efficiency and reliability of the UPS. Furthermore, the configuration might be related to harmonic mitigation. Depending on the UPS design and the types of loads connected, harmonic currents can be a concern. A carefully designed phase connection scheme, including the series connection of LON and L2, might be implemented to help reduce the generation or propagation of harmonic currents within the system. This can improve power quality and prevent interference with other electrical equipment. To delve deeper, consider the impedance characteristics of the system. The series connection affects the overall impedance of the circuit. This impedance can influence the fault current levels and the performance of protective devices like the 1600 amps breaker. Engineers carefully calculate and considered these impedance characteristics during the design phase to ensure proper coordination of protective devices and to minimize the impact of fault currents. Let's also touch upon grounding. The grounding scheme of the UPS system is crucial for safety and proper operation. The location of the ground connection and the way it interacts with the phase connections can influence the system's susceptibility to noise and its ability to handle ground faults. The series connection of LON and L2 might be part of a comprehensive grounding strategy designed to enhance safety and performance. Keep in mind that UPS systems can have different architectures and designs, so it's always crucial to refer to the manufacturer's documentation for specific details about the wiring and configuration of a particular UPS model. General principles of electrical engineering still apply, but the specific implementation can vary depending on the application and the manufacturer's design choices. Finally, efficiency is a primary design goal in UPS systems. The series connection of LON and L2, while primarily intended to achieve the required voltage level, might also contribute to the overall efficiency of the UPS. By minimizing the need for additional voltage conversion stages, the series connection can reduce energy losses and improve the UPS operating efficiency. These efficiency gains translate to lower operating costs and a reduced environmental impact.